please, Denis.
Good morning. Yes, my job is to insure satellites, and I will speak about collision risk. While I totally agree with my presentation that this is not the only concern. I will present you the view from a space insurer. So first, an overview of why there is insurance in space and if we cover collision risk or not. Then I will present you the consequence of collision we have observed as a space insurer, and then what is done to perform risk assessment and what needs to be done going forward. So first, there is a need of insurance in space because there is a huge concentration of value and risk. Satellite, especially in GEO, can be in excess of $200 million. And the probability of failure, including the launch phase and the full life cycle of the satellite until end of life, can be between 10 and 25% in GEO and between 5 and 50% in LEO. So when you combine the value and the probability of occurrence, the risk is there. That's why there is space insurance. We cover all risk during a period of 1 year. So typically, we have launch plus 1 year cover. We cover the launch and the first year of operation. And then after, we have in-orbit policy covering 1 year of operation until end of life. But to analyze and finalize a contract of a launch plus 1 year insurance cover, we negotiate the contract 1 or 2 years in advance. And so we perform the risk analysis 1 or 2 years in advance. So our need is to know the probability of collision during a period of 1 year, but 1 or 2 years in advance. So potentially with more constellation being launched between these two dates. So we do not need a good accuracy of data on the short term, but we need good trend to be able to calculate our own probability. So as of today, space insurance is covering the risk of collision, but we need good data. So what are the consequences of collision we have observed? First, impact on solar arrays. Sometimes we see a loss of few percent of available power because of loss of solar array strings or cells, and they are potentially due to debris. We are not sure of that. They are potentially due to space weather, but when we take overall the risk of space environment damaging solar arrays, we see that some satellite design seems more susceptible than others to such space environment. Then we can see as well impact on power harness, especially when the power harness is located outside of the satellite structure. In such a case, we can lose 50% of the satellite or even 100% of the satellite. We can have as well impact on the thermal control. The thermal control is critical key for a satellite to maintain the units of the satellite within their qualification temperature range. And if you have an impact on the debris, the heat pipe could have a leak. And if you have no redundancy on the heat pipe, then you can lose the thermal control and lose the satellite. This happened already. And sometimes just unknown failure mechanism. We just lost the satellite, no more telemetry, no more signals. And by combining the data and the probability of collision we can estimate from the ground, we estimate there is a probability that the failure is due to a collision, but we have no guarantee at all. So here I put some example of public information just to illustrate we can have a collision in GEO, in GTO, and in LEO. But what I wanted to say is that we observe since 3-4 years that in GEO, because our portfolio is mainly located in GEO because this is where we have the biggest asset of satellite, we have seen some events that are most likely due to a collision even in GEO. Whereas 10 or 15 years ago, we had no anomalies due to collision. So the risk is increasing even in GEO and materializing itself by failure and loss of mission. So overall, still difficult to be sure when the damage is due to a collision, but as well it's due to space environment, and we are working to get more better analysis on that. So in terms of risk assessments today, so similar graph coming from ESA showing the number of space objects increasing. We are today about tracking about 35,000 space objects, mainly in LEO. So this poses a long-term risk for satellite, of course, damage, as I said, but as well orbit pollution, and maybe more need to perform avoidance maneuvers. And so the challenge for space insurance is first to estimate the probability of collision, of course, but the intrinsic failure probability of a satellite, so failure due to failure of unit, not due to collision, is still higher than the probability of collision. So as of today, it's difficult to focus all efforts to have better probability of collision assessment. And second, as an insurer, we need to encourage responsible behavior. But here again, the conjunction probability, which is the probability to have a collision or less, are not accurate enough. So we need more awareness, we need more data, we need more rules. So tomorrow, the population of space objects will continue to increase. This is a similar computation as Mina, but with a different angle. You have the number of satellite launches per launch year, and the color gives you the orbit. So in blue, you have the GEO, so small number of satellites, pretty stable. And then you can see in Leo, orange and green, the number of satellites is really increasing. In green, you have Starlink and OneWeb. But even if we put aside these two big constellations, in orange, you see there is a huge increase in the number of CubeSat and SmallSat in Leo. And most of these satellites, including Starlink, have no propulsion. So they do not, they cannot perform a collision avoidance maneuver. So we need more reliable data to ensure the maneuver is going in the right direction. And the accuracy of such a data shall be demonstrated. If we have such a demonstration, we can, as an insurer, ask the operator to apply collision avoidance maneuver each time there is an alert. If not, they can say to us, okay, I'm not sure, I'm not going to be closer to the debris if I perform the maneuver. In case of collision with two insurer satellites or with one very high value satellite, there will be a bigger awareness of the space community, especially space insurance community. And as you can understand, insurance premium will increase. And some orbits might be difficult to operate and to insure. As of today, one space insurer has stopped insuring LEO just because of the risk of collision. So we should make sure to protect space now. So what needs to be done going forward? We need to manage space environment to ensure long-term use of space on 4 pillars. The first, improvement of the data, better data sharing, better identification of satellites, better knowledge of density of objects, potentially in-orbit sensors to be able to detect a risk of collision, and maybe more important, working on the lesser non-trackable debris. There are debris that are too small to be tracked from the ground, but big enough to be able to damage a satellite. Then improve protection against impacts through redundancy and a better structure. Work on collision avoidance, or working on the accuracy and timeliness of conjunction alerts, and of course, debris prevention to ensure that end-of-life disposal rules are applied. Of course, they are applied in Europe, mostly in US, but there are other countries active in space. And what about asking a mandatory ability to move, a mandatory cleaning of the orbit, and ask every satellite to be compatible by design with active debris removal. To have mechanical parts such as a servicer could wash the satellite and put it in gravity orbit or into the atmosphere. So as a conclusion, and I'm pretty sure you will agree with me that understanding space environment is key. And with science and data, business and space sustainability, we shall all work together with these 3 topics, working on correlation and prediction. At AXA XL, we are already involved with several space stakeholders to be sure to encourage responsible behavior. And you know, as already said, the risk between debris and the space weather is connected, because the space weather can affect the atmospheric drag and can modify the probability of conjunction alerts so that one operator could rush and have a very different probability of collision on the very short time. And so the risk is connected, but the solution can be connected as well, because we need more data from space. So we need more sensors to be able to get us more data, both on space weather and on the risk of collision. Thank you.